Well, welcome everybody. My name is Sam Wynns. I am a biologist and a science educator here at Cabrillo National Monument. It is our mission in the National Park Service to preserve and protect all native plants and animals that call this place their home. And in order to do that, we have to study everything that lives here, right? Because we can't protect what we don't know about. So we study almost everything, right? We study our plants, we study all of our amazing creatures and our tide pools, our rocky intertidal zone, we study reptiles and amphibians. And today we're going to be talking about one of my favorite taxa or groups, birds. Because if you know me at all, friends, you probably know that I am a certified bird nerd. Any other bird nerds in the room? Raise your hand if you love birds. Yeah, I know there's some bird nerds in here. That's awesome. Okay, my friend, would you like to offer up what you like about birds? What's cool about birds?
They're cool because
Hang on 1 second.
Light.
Here.
Oh, you want to use a microphone?
Ooh, fancy. Yeah, only if you feel comfortable with it.
Can I tell a fact?
You can tell a fact. Yeah, go for it, friend.
Birds actually, for their wings, their bones don't expand for their wings. Their bones are only at the top, so they only rely on their skin to fly.
That is awesome. I love that you already are throwing some bird knowledge here. Man, you're going to be teaching me some stuff too. I love it. We can exchange some bird knowledge. Yeah, cool fact about birds, right? Sandy, what do you love about birds? Thank you for sharing, friend.
They're colorful and they give me lots of entertainment.
Yes, they do with their funny behavior sometimes, right? They're colorful. What about anyone else here, a bird nerd in the house? Let's do one more. Yeah, Karen, what about you?
I love trying to learn their songs so that I can identify them when I can't see them, but it's very challenging because their songs are so different.
Their songs are so different and varied. Yeah, and you hit on a really nice point is that birds who sing, not all birds sing, but birds who sing, they all have their own unique song, so you can actually identify birds by song, except for the birds that mimic other birds. But even then, if you pay close attention, you can kind of figure out even those tricky mimicky birds as well. Yeah, exactly. There's so many cool things about birds, so many things to love. They're from their beautiful plumage or feathers, right, to their melodic songs, to their funny little mating dances, right, incredible structures, incredible shapes, right? But today we're going to be focusing on my favorite thing about birds, which is their ability to fly. Because I'm here to tell you, friends, that birds are a veritable flying machine. We think as humans that we're so cool and we build helicopters and planes and drones and we've really got it down. But scientists actually look to birds to influence what they build because birds do it way better than anything we can build. It's a whole branch of science called biomimicry, where we mimic or copy something that happens in nature. And so let's see if we can get this little video to work here. Will it work?
Did that bird
Hold on.
have goggles on?
Let me try it. That bird does have goggles on. Okay, let's see if we can get this to work. Will you work for me? You were working earlier. Okay, well, we don't need to watch the video. Of course, it works when you test it, and then when you are actually doing it, it doesn't work. We don't need to watch the video right now, but this is actually a lab at Stanford called the Lentic Lab. I highly recommend you can find this on YouTube after we're done. And they've actually trained this adorable little Pacific parrotlet. It's a bird that's about this big, named Obi, after Obi-Wan Kenobi, to fly from one perch to another. And what he does is he flies through lasers. And those lasers map exactly, so precisely, all of his movements as he flies through them. And then they take that information and they give it to aerospace engineers so that we can make our flying craft much better. Now, fun fact, someone asked, did that bird have goggles on? He does have goggles. Why do you guys think that they made these little goggles for Obi? I think Brenda saw your hand first.
Because for the goggles, they have to put it on because the the eyes.
Yes, very good. Lasers are high energy, right? And they don't want him to damage his eyes or his retinas as he's flying through those lasers. So they crafted these tiny little goggles to put on his head, which I think is the most adorable thing. So I would encourage you, after we're done here, to look at some of the videos from the Lentic Lab, the Stanford researchers, and the work that they're doing with biomimicry. So when you guys think of birds flying, what do you think about? How do birds fly? What parts of their body help them to fly? This is not a trick question. What do you guys think about?
Their bones.
Their bones, that's a big one. Their skeleton, yeah. What else? Anything else?
Feathers.
Feathers, wings. Were you going to say that, Henry? Yeah, exactly. I saw your hand. Thank you, friend, for raising your hand. Yes, exactly, right? Feathers, wings. And I love you touched on their bones, their skeleton, right? Because actually, pretty much everything about a bird's body is adapted for flight. You can actually call flight kind of their primary adaptation. Okay? Eve, did you have something you want to add?
They have a bladder.
They don't have a bladder. You're right. They have a cloaca. All reptiles have a cloaca.
So they're not carrying a bunch of cargo around.
Mm-hmm. Yeah, and we're going to get to that, actually. So you guys, you may not even need to be here. You can come up and lead this talk, in fact. You may know all of this, right? But you have your wings.
That's my fact.
That's your cool factoid. Yeah, very much. And we'll get into like how that works here in just a little bit. So wings and feathers, right? Of course, they have to have those to fly. Their skeleton is heavily adapted for flight, like you were talking about with bones. Their musculature, right? Their musculatory system, their muscles. How they breathe, or their respiratory system, heavily adapted for flight. And, as Eve touched on a second ago, their waste, their excretory system, how they get rid of all of that waste, right? So we're going to go through this one by one. They're amazing adaptations for flight. So let's start with the obvious. Feathers. All right, so I actually have Lucinda, if I can get you to come up and help me. Everybody say hi, Lucinda.
Hi, Lucinda.
Lucinda is my youth apprentice here, and she's helping me out today. Lucinda, if you could go ahead and pass around these feathers here, and then these magnifying glasses. So you might share with your group, right, if you're in a couple or in a family group, so go ahead and share a feather and a magnifying glass. What I want you to do is to take a close-up look at these feathers in the magnifying glass, okay? Before we get to that, this is the part where you go, aww, aww. Because the feathers that you're actually looking at come from this bird. This is my parrot, Peep. She's a green-cheeked conure. She's a small parrot, about this size. And those come from her tail feathers, actually. And no, I did not pluck her. That would be cruel. Birds actually molt or shed their feathers at least once a year, usually more than that, to prevent any damage, right? Because over time, they can get damaged from mites or sun or whatnot, life, right? So they need to keep them in good working order, so they shed them naturally. And I've just been collecting her feathers to use them as an example. Okay, so feathers, what about them makes them amazing for flight? Well, it's all in the structure, okay? And we're gonna actually have to take a really close-up look, because the magic sauce is in a microscopic level, okay? So here we go. We've got a little feather. You've got some in front of you. Those of you at home can follow along if you were able to gather some feathers ahead of time. You have this hard part that goes at the center, it's a little off-center, the feather. That's called the rachis. And that hard part is where all the soft feathery bits, or the vein, connect to. Okay, you'll see the soft feathery bits here. At the bottom, you'll notice that there's no feathery bits down at the bottom, right? It gets a little fatter, it's just hard and stiff down there. That's the calamus, or the quill. That's the part that actually sticks in the bird's body, okay? And fun fact, for those youngins in the room, right? This is actually, before we had ballpoint pens, people used to write with quills from large birds, right? They would dip this in ink and then write with it. So like, for instance, the Declaration of Independence, right? Signed with a quill here. But the magic part is actually all throughout this area. And we're actually gonna zero in on this tiny little window right here, okay? So here we go. We're zooming in. Boom. So here we have, again, the rachis, right, that hard part. And then you have the soft feathery bits, and they are kind of in sections here. This is called a barb. It comes off, so there's one barb, here's another barb, here's a third barb, right? So you have these parts that come off of the rachis, like so. And you have barbules that go over it, cross-link it. So it looks like a tennis racket, or it looks like a waffle, or a waffle fry, right? Kind of like these cross-linked parts. But what's really magic about it is this. These tiny little hooklets called barbicels. Because what those hooklets do is they actually connect all the feathery parts together, right? They hook into the feather structure next to it. You can see as I'm kind of demonstrating with my hand, right? To make it so that it's like one solid surface where air can flow over and under, but not through. Now I want you to try something with your feather. Let me grab mine here. Okay, so you can see it's like one solid surface, right? Air passes over and under, but not through. It's flexible, it's strong, right? And it's aerodynamic. However, what happens if you do this? Uh-oh, what's happening here?
So the bird's got to do a lot of grooming.
Yeah, exactly. So what's happening is those little barbicels, those little hooklets, they're coming unzipped, like a zipper. They're coming unhooked from the rest of it. So now you've got this floppy feather, right, like this. Do you think this is helpful for flight, to have a feather like that? No, why not?
It's air through.
Yeah, right? Let's air through, right? It's like when you have a kite and there's a hole in your kite, it doesn't lift, right? You need that solid surface. So how does a bird fix that? Well, Eve touched on it just a second ago. Craning. You guys ever seen a bird moving a feather through its beak before? You might, if you pause long enough to watch bird behavior. They do it pretty often, right, if they're healthy birds. And they're doing things, they're cleaning their feather, they're taking dust and mites and various things off, but they're also reconnecting all of those little hooklets. They're re-zipping that zipper to make their feather nice and solid once more and aerodynamic. Make sense? Any questions about that? Pretty cool stuff. I can try to fix it, right? But I don't have the precision of a little bird beak. I need my bird peep here to zip this feather back up for me. Eamon.
So I can see the bird can only touch part of his own feather. What about the rest?
Oh, that is a great question. Yeah. What do you think, Henry? Do you want to add to that?
Sam, can you repeat?
Yes, let me repeat the question. Yemen asked, sorry, so just so the people on Zoom can hear us, and then I'll get to you in 1 second, Henry, okay? So Yemen asked, like, the bird can only reach some of his feathers, but what about the feathers he can't reach, like the feathers on the top of his head? Henry, did you have something you wanted to add to that? Go for it, Henry.
What if there's a hole, like, right here, but then it connects back? Like, doing damage?
A hole where? Can you show me? What if there's a hole where?
Like, here. But then it connects back.
Oh, but then it connects back. Yeah, so he re-zips it? No, once it's re-zipped, it's totally fine. So it's just like your zipper, it doesn't get broken when you unzip it, right? You can re-zip, unzip as much as you want. It's the same thing with hooking those little hooks together. Very good. So you asked a really good question, Yemen. Birds almost always flock together, right? So what happens is if they can't reach the top of their head, who can reach the top of their head? Their buddy, their flock, right? And this is why anyone who's considering becoming a bird owner or a parrot owner, you actually want to make sure that you have a lot of time to spend with your parrot because they're used to spending wingtip to wingtip, right, with their flock their whole entire life. So they need a lot of attention and care, okay? Or give them another bird as their flock. Yeah, very good question. Any other questions? Henry, you want to add something?
What if the birds don't live in flocks?
What if they don't live in flocks? That's a really good question. I actually don't know of any birds who don't have bird friends. Can you guys think of birds that are solitary birds? I can't think of one. Yeah.
Are there birds that maybe hang out most of the time alone and then very rarely hang out together? Like, I don't know, I never think of two condors.
Yeah, two condors together. They do, yeah. Yeah, but, yeah. But there's, at some point, there's always a bird, right, that they can preen, right? But you're right, there might be some, there's some that are definitely like extremely flocked together, always together, all the time. Like our bush tits here, right? They're always in a flock, moving from bush to bush, eating insects together, right? And then there are some birds like raptors that are more alone for a lot of the time, but then they do end up with other birds that can then help them out and bring each other at that time. Yeah, good point. Other question? I like how deeply you're thinking about all this. This is fantastic. You got your scientist brains going. Yeah.
Is it possible to like groom like a feather with like your hand? Because when you like demonstrated like the push down and it's like and it got all raggedy.
Yeah.
I did that too, but then I started pulling it up, so then it turns back to normal and I actually fixed it.
Yeah, we can fix the feathers pretty well, but not as well as a little bird beak, that comes down to a little point, right, that can help put it together. But you're right, see, it's fixed pretty well. It's just not perfect. You need a bird to make it perfect. Yeah, very good point. You were able to kind of fix it a little bit. Okay.
Do you just have one bird?
Myself? Yes, I just have one parrot, but my husband and I, we often work from home, right? We're home a lot with her, so she gets a lot of attention. She's very spoiled. And when we go away, we board her at the Avian vet, so she's with people who love birds and other birds and everything.
I'm just curious. I mean, I used to have a parrot. I need to like, do a lot of grooming.
Yes, and so we do groom her head, actually.
Yeah.
You're right. So we do. We take our fingers.
They can't get their head.
Exactly. So we do groom her head for her, which she resists a lot of times. It's like a kid not wanting to take a bath, honestly. Yeah. We do groom her head for her. You're right. Yes. All feathers are important, but they can't reach their head.
So why do they use it if it's not for flight?
Oh, that's a really, really good point, Jed, if it's not for flight. So it's not only, so preening their feathers are not only for zipping up the flight feathers, right? It's also to clean them, so clean the mites, clean off dirt. When feathers emerge from a bird's body, they're actually coated in wax. So when they come out, they can't come out in this big glob, right? That would hurt for this big thing to come out of their body. So they're actually encased in wax, so they're tiny and skinny when they start to come out. And then the birds preen the wax off and the feather kind of unfurls. Does that make sense? But you bring up a really good point because there are different types of feathers. So who's ever slept under a down blanket before or in a down sleeping bag, right? Down feathers are not flight feathers, right? You may notice that they're kind of, floppy, right? Small and floppy. Yeah, they're soft. Does anyone know what they're for? It's the same reason we sleep in a sleeping bag.
Insulation.
Insulation, yeah, exactly, for thermoregulation, to help keep them cool or warm as needed. So that's kind of the underlayer, right? These are what we call contour feathers or flight feathers, right? These are the types of feathers that help them to fly. Very good. And this is a really cool shot right here in an electron microscope. So at an atomic level, right, we're looking at this feather. So again, here's that rachis, that hard part that goes kind of towards the center of the feather. The barb, right, that comes off of it. And then we'll zoom in even more, right? Here's the rachis again, here's the barb, and you can even see the tiny little barbules, the tiny little hooks in this electron microscope hooking into the feathery bits next to it, right? Zipping up like a zipper. All right, wings. Now this can get really complicated. Just ask any aerospace engineer. So we aren't gonna go into crazy depth here, but let's just take a look. It's all in the shape. How would you describe this shape right here in purple that I am using the laser on? How would you guys describe that? Is that a cylinder? What is it? Yeah.
It's like kind of like a blob shape.
Kind of a blob shape, right? Yeah, kind of asymmetrical, right? Oblong in shape, right? So, and this is the secret sauce. The magic is in the shape. Henry, do you want to add to that?
It looks like it's designed for flying.
It is designed for flying. Why do you say that, Henry?
Because, like airplanes' wings kind of look like that.
Bingo, Henry. Yes, airplane wings look like this. And what came first, the bird or the airplane?
The bird.
The bird, you're right. So we, again, biomimicry, we looked at birds and their amazing wing shape and copied it in our flying vehicles because it's way more aerodynamic. And here's how, okay? So because of this kind of magic oblong shape, this is the part that would stick, this is the shoulder right here of a bird, okay? This is the wing, so it gets wider, the widest part of the wing, and then it goes down to a narrow point at the end, okay? That shape actually makes it so that their air pressure, right, there's less pressure down, more pressure up, and what that means is that gives that bird lift. So think of your kite again. You want pressure, you want air underneath that kite to lift it up into the air, okay? And it makes airflow faster and slower above and below, which changes that pressure, which makes them lift up so they can get up into the air and stay up in the air. So there's basically 4 forces of flight. 2 are what we call positive forces. So there are 2 forces that help a bird lift up and fly and move through the air. 2 of them are negative forces, right? They're forces that bring a bird down to earth or slow it down when it's in the air. So which ones are the positive forces? Who'd like to take a stab at that? What helps a bird lift up and get up into the air, stay up in the air? Go ahead, Henry.
Thrust and drag.
Thrust and drag. Very good guess, my friend. So thrust is definitely a positive force, right? That's so they can thrust through the air. Drag actually drags you down, slows you down. That's a negative force. Yeah, friend, go for it.
Thrust and lift.
Thrust and lift, you got it, exactly. So good teamwork there, guys. Very good teamwork, right? So lift, again, think of that kite, lift. You want more lift so they can get up into the air, and you want more thrust so they can thrust through the air. Versus weight, that's gravity bringing you down. Ugh, isn't it always bringing us down? It is. Always bringing us down. And drag, which slows you down. So this magic shape of a bird's wing, this kind of oblong shape, maximizes that lift and that thrust and minimizes that weight and that drag so a bird can get up in the air and stay up in the air. All right, here comes something really cool, the skeletal system. I'm going to need some help from you, Lucinda, if you could actually pass out these 2 skeletons. These are actual skeletons. They're from a quail, and we're going to just pass them around. I want you to take a close look as they come by you. Maybe even use your magnifying glass to take a close look as they come. Maybe you can start one there, Lucinda, and then one over here. Yeah. That'd be awesome. And here comes audience participation time, my friends. My favorite time. All right, who would like to come up and be my assistant in an activity? And to sweeten the pot, I'm going to tell you, I have a prize for you. You get a reward for coming up here. Do you want to try it?
Yeah.
Okay, come on up, my friends. Come on up. Okay, I'm going to give this one to you. We're going to test a question, a hypothesis here. And that question is, are bones heavy? What do you guys think? Are bones heavy?
What do you mean by heavy?
What do you mean by heavy? Are bones fairly heavy? All right, my friends, so let's see how heavy they are. What you're going to do, you're going to take this bone and you're going to pump some iron with it. You're going to pump some calcium carbonate, okay? So hold on 1 second. On the count of 3, you're going to do this for 20 seconds, okay? As fast as you possibly can. All right, you ready? Ready for it? 1, 2, 3, go. Okay, 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, 6, 1,000, 7, 1,000, 8, 1,000, 9, 1,000, 10, 1,000, 12, 1,000, 13, 1,000, 14, 1,000, 15, 1,000, 16, 1,000, 17, 1,000, 18, 1,000, 19, 1,000, 20, 1,000. How are you feeling?
It is really light when I just move it.
Oh!
It's really light when I move it one direction.
Yeah.
Since it has like little holes in it.
Ah.
The wind goes through.
You think it's really light in one direction, but what about the other direction? How's that feel?
It's kind of hard.
It's kind of hard, huh? Yeah. Well, I think we have a Superman here, everybody. We give you a little round of applause. You can go ahead and pick your prize. Go ahead and quickly pick your prize. All right, very good. So, spoiler alert, this person is very strong, okay? Because bones actually are pretty heavy. And what do you think? Do birds want to be heavy? Does that help them to fly? What do you think? Henry?
So I think this was a group, but their bones are hollow.
Oh my gosh, Henry, you're getting to something here in a second. Yeah. So do birds want to be heavy to fly, or do they want to be light? Light. You got it. So a lot of a bird's skeleton is adapted to make them lighter. Okay. And so birds have hollow bones which Henry was just talking about a second ago. They have something called reduced bones. They have something called fused bones as well. So let's talk about hollow bones for a second. Birds actually have hollow bones for a couple of reasons. We're going to do a little compare and contrast here. Here we have a human bone versus an eagle bone. What do we notice about the human bone versus the eagle bone? Raise your hand, offer up. I've been calling on Henry a lot. Anyone else want to offer up? Lucinda, let's go for it.
Obviously has looks like a lot more muscle, or not muscle, but it has more stuff in it than the eagle bone, and the eagle bone looks a lot.
What do we call that, marrow?
Yeah, exactly. It's got a bunch of stuff in it, right? Or marrow, right? Bone marrow. It's pretty dense compared to this eagle bone, which is largely hollow. And friend, the bone that you were using, does this come from a bird, do you think? That'd be a really big bird, wouldn't it?
Pterodactyl.
What kind of animal do you think this could be? It's not a bird. Spoiler alert.
Is it a whale?
It's a whale, exactly, very good. Yeah, so it was a whale vertebra that you were actually, a great whale vertebra that you were pumping iron, right? And for mammals, those who are terrestrial dwelling mammals or in the water, right, it doesn't matter if you're heavier, right? Because they don't have to get up in the air, they don't have to fly. So it's okay that they're dense with all that bone marrow, right? Here's what it actually looks like. This is a real bird bone right here. And fun fact, it does make them lighter, but actually the primary reason that birds' bones are hollow actually helps them breathe. You might be like, huh? How does that help them breathe? But we're going to get to that in a little bit in the respiratory system. For now, though, is it entirely hollow? Totally? No. What could these structures be for? What do you guys think?
Strength.
What's that?
Strength.
Strengthen and support, exactly, right? They're kind of like struts. Because think about it, if you had a completely hollow bone, that would be very brittle, right? It'd be very weak. And birds have a lot of force when they fly, right? There's a lot of forces on their body, so they need to have strong bones, yet light bones. So they're primarily hollow, but they have these reinforcing parts, throughout here to make them strong and light. All right, and I mentioned something earlier that birds have fused bones. What could we be looking at here in green? There's a hint on the screen. What bone is this? Yeah, exactly. It is a collarbone. Everybody go ahead and touch their collarbone. Do our collarbones look like that? No, right? The birds' collarbones are actually fused together. And the reason for that is it makes them stronger, right? So for those forces of flight. And also it acts like a spring almost, where it stores potential energy. So think about as they're flying, boom, there's energy. It helps them kind of release that downward stroke, right? Up and down. Acts like potential energy. Reduced bones, and you actually mentioned this kind of at the beginning of our talk here. Birds, again, bones are heavy. Even hollow bones are heavy, right? They don't want to have extra bones just floating around. Bones they aren't using. So their bones are as streamlined as they can possibly be for function. Okay, so I think there's a really good example here, the fibula and the radius. Do you see how tiny and skinny the radius and the fibula are? And you can actually see them on the quail skeletons when you look, right? Tiny and skinny. You want to pass around the quail skeleton a little again? Keep passing it around, folks. Okay, take a look. Right? So they are the minimum amount they can possibly be to still do what they need to do for birds. So reduced bones are an important aspect. We also have fused bones. So bones that are fused together, right? Which actually helps lighten the load. So think about this. If you had bones end to end versus fused, there's less surface area, there's less volume. It helps lighten the load. It also helps strengthen those bones. Yet again, that fused collarbone, right, helps strengthen that bone for flight, for those heavy forces. Now here's a question you may have never thought about. Do birds have teeth? No, right? What do they have instead?
A beak.
A beak. And what is the beak made out of? Anyone know? Take a guess?
Protein.
A protein. It's the same protein that makes up our hair and our fingernails.
Keratin?
Yeah, keratin, that miraculous protein that is very lightweight, very strong. You see it a lot in nature. It's also bird feathers are made of that, baleen of whales, rhinoceros horns, right? Keratin. And again, teeth actually are pretty heavy. They're made of calcium carbonate. So birds adapted this keratinous beak. It's much lighter, yet strong, right? Can still do the trick. Now, you might have noticed on the bird skeleton, this structure right here. Everybody go ahead and touch their sternum, their chest bone. Does it look like that?
No.
No. How is it different? Go ahead, Fred.
It's not really hollow. It doesn't have like
It's not flat.
It's really flat and it's not hollow.
Yeah, it's very flat, right? This has this big structure, like pyramid structure coming off. That's called a keel. A keeled sternum, like the keel of a ship moving through the water, right? A keeled sternum. And why do you think that birds might need a keeled sternum for? What do you guys think? Want to take a guess? Lucinda?
You mentioned respiratory system earlier. That it has something to do with that.
Ooh, you're close to it. Yeah, you're close to it. It does have to do with another system, and that system is the musculatory system. So that keeled sternum is a big surface area for the enormous pecs of a bird to attach to. Okay, now I need another friend to come up. Henry, you want to come on up? I love it. Thank you, friend. Okay, so you are going to pretend you are a bird. You ready? You're going to hold out your hands, your arms. We're going to pretend you're a duck going on a very long migration of thousands of miles. So when I count to 3, what I want you to do is to move your arms up and down like you were flapping really hard and as fast as you can for 20 seconds. You ready? Okay, 1, 2, 3, go. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5,000, 6, 1,000, 7, 1,000, 8, 1,000, 9, 1,000, 10, 1,000, 11, 1,000, 12, 1,000, 13, 1,000, 14, 1,000, 15, 1,000, 16, 1,000, 17, 1,000, 18, 1,000, 19, 1,000, 20, 1,000. Okay, you can stop. Whew! Everybody give Henry a round of applause. Sorry, we forgot to give you a round of applause earlier. What's your name?
Connor.
Connor. We'll give Connor a round of applause, a belated round of applause as well. Yeah, Connor. All right, Henry, how was that? Was that easy? Could you imagine doing that for thousands of miles without any sleep all day? Yeah, right? Okay, friend, you can go ahead and pick your prize right up here out of these items right here, my friend. Yeah, you're right. They have to be ripped to fly, all right? They need huge pectoralis muscles, as you see here, and hence the keel, which those pectoralis muscles attach to. Now, fun fact, flightless birds actually don't have a keeled sternum. They have a flat sternum like we do, because they don't have to have those huge pec muscles to fly, right? Those are called ratites. So a flightless bird like an emu and ostrich, for instance, are a really good example of that. There's something else that's really cool about bird muscles as well. Who's had Thanksgiving dinner before?
Yeah.
I hope all of you, right? I hope all of you have. Have you been asked at Thanksgiving dinner, do you want light meat or dark meat? Ever been asked that? Or sometimes people say red or white meat. Yeah, well, what's the difference? We can see visually there's a big difference here. This is red meat, that's white meat, right? Red meat, they're made of different tissue, right? They're made of different muscle fibers. And what gives them their color is actually the composition of various different proteins in their muscles. So red meat has a lot of myoglobin in it. Myoglobin is that oxygen-carrying molecule for the storage of oxygen. So those big muscles that are going to be working really, really hard for a really long time, lots of concentration of myoglobin. So you, for instance, find red meat in birds that migrate long distances, right, that have to fly thousands of miles. They need those oxygen-carrying molecules in their muscles to keep them going, right, to keep them energized as they go. So for instance, ducks. So if you've ever eaten duck versus chicken, ducks are almost entirely that dark meat or red meat versus chicken, which do chickens migrate thousands of miles every year? No, right? Or turkeys, they do not. But what white muscle fiber is good for is actually powerful explosive takeoffs. So birds, if you've ever startled a chicken or seen, grouse startled on TV, right? People were hunting out there in nature and they just jump right up from the ground and right away, right? That takes a lot of quick energy. And so they don't have that myoglobin. This is for quick energy, right? Different protein composition in their muscles. And this is incidentally why people don't ask you when you have a steak, right? Or when you have a pork chop, do you want red meat or white meat, or do you want light meat or dark meat, right? There is no difference, right, when it comes to the mammals. It's an adaptation for flight. Okay, now comes one of the coolest systems in my mind. Respiratory system, and I do need another assistant. Anyone else? I would be willing to take adult assistants too. Yes, come on up. I love it. What's your name?
Ashley.
Ashley, thanks for being the guinea pig today. I should ask, do you have asthma or any sort of respiratory? Okay, great. Okay, so Ashley, on the count of 3, I'm going to ask you to take in the deepest breath you can possibly take and hold it.
Okay.
And then wait for my instruction.
Okay.
You ready? 1, 2, 3, go. Okay, without letting it out, take in a whole nother breath. Can you do it? No, you can't. Go ahead. You can breathe out. Go ahead. You can, right? Very good. Thank you, Ashley. Go ahead and pick one of your prizes there. Of course you do. Absolutely. That's not just for kids, for everybody. You're welcome. Ashley, thank you, Ashley. Let's give Ashley a round of applause. Yeah, very good. So we can only carry 1 volume of air at a time in our body. We have to breathe in and then breathe out. But as you can imagine, flying, man, they need a lot of oxygen to power themselves, right? It takes, think about if you ran a mile or you're working out, right, how your breath starts coming hard and fast. Think about flying for thousands of miles with a very fast wing beat, right? That's crazy. You need a lot of oxygen. So birds actually have something called continuous breath. They can actually hold 2 volumes of air in their body at any given time. So that oxygen is always going throughout their bloodstream and through into their muscles and everything they need to power themselves for flight. Well, how does that work? Well, I touched on that a little bit ago when we were talking about the skeletal system, right? I mentioned that there's a structure that helps them in their skeleton, and these are something called air sacs. Okay, so birds have lungs just like we do, but they also have these air sacs that are spread throughout their respiratory system, around their body. They have the anterior air sacs, which are kind of at the top of their body, and their posterior air sacs, which are at the bottom of their body or behind their lungs, right? And those air sacs actually expand and contract into their hollow bones. So that's how the hollow bones help them to breathe, right? It gives them that extra space for those air sacs where they can have continuous breath. Well, how does that work? So we're gonna look at a really simple diagram just to kind of break it down here, okay? So here you have those air sacs that are kind of at the front of the body, at the top of the body, the anterior air sacs that I pointed to a second ago. We have a representation of the lungs, and we have those posterior air sacs back here at the bottom of the body, behind, underneath the lungs, right? This is the bronchus. That's the tube that goes into your respiratory system, right? Like you breathe in through your nares, goes down into your lungs, right? That's the bronchus. So let's pretend, friends, that you are a tiny little baby chick who's hatching from their egg and taking their very, very first breath ever, of all time. Okay? So you're taking your first volume of air. It goes through your nares, down your bronchus, into those posterior air sacs, which expand. Okay, then you exhale for the very first time, and those posterior air sacs contract and push that volume of air into the lungs. Okay, then you take your second inhalation. You breathe in a second time, and the air that was in the lungs gets pushed into those anterior air sacs, which expand. Then your second exhalation, those anterior air sacs contract, and it goes through the lungs and back out the bronchus and out of the body. But that's only 1 volume of air. Let's look at it with 2 volumes of air. So here we are again. You're a tiny baby chick. You're taking your very first breath. You inhale, it goes into those posterior air sacs. You exhale, they go into your lungs. Now, when you take your second inhalation, that first volume of air goes into those anterior air sacs, like we just showed you. But a second volume of air comes in through the bronchus into the posterior air sacs. So you have 2 volumes of air now in this bird's body, 2 volumes of oxygenated air. Second, in exhalation, the air that was in the anterior air sacs goes through the lungs and out the body. Meanwhile, the second volume goes into the lungs. They take another breath. Oh, here comes a new volume of air, and so on and so forth forever. So it's just continuous breath, just constantly coming in and out of them.
So,
Lucinda.
so as the air goes into our lungs and it comes out, like the processes with inside our lungs and it creates it into carbon dioxide, how does that work for birds where they have the 2 air sacs? Like when does that process happen, or does it happen, or how do they go from like when in the lung or in the diagram does that process happen?
Yeah, great question. So she's asking about like when does it, as you're breathing out, you're getting rid of waste products like carbon dioxide, right? So gas exchange, right, where is gas going into your cells, right, and then kind of coming back out, is happening in the air sacs and in the lungs. So it's kind of happening at all times. Does that make sense? Yeah. Karen, you have a question?
So the sacs, I mean, the way it processed in my mind was that they're kind of like holding areas for the air to go into the lungs, but what I just heard you say is they're doing more than just holding air.
They are doing more than just
Okay.
holding air. Yeah, as far as I know, we can double check me on this, but this is what my understanding was. Henry, did you have something you want to add to that?
How can, when they breathe out, the air in the first air sac, how can it come in while the air in the next air sac, how can that air come out if
Yeah.
the other air sac is kind of
Yeah,
in the way?
that's a really good question. So let's go back. We'll go back one. Okay. Nope. Here, second inhalation, air sacs expanding. Okay, so see how the second inhalation, this one is coming in, it's going into the posterior air sacs. Okay. And then this air is actually moving, forced to move out. Well, this air is coming into the lungs, so it's kind of a pressure differential, right? As one is going out, another is coming in.
But the air in the first air sac is going a little slower so that the air in the next air sac can go out.
Does it travel slower, or?
That's a good question. I actually don't know the answer to that. So there's something about the bird that it allows it to, and maybe it's sequential. So this is a good research question. And here's what I love. I know a lot about birds. I don't know everything about birds, right? And I love doing presentations like this because people will ask me questions I never thought of before. You did just now. So this is our research question of the day. After we're done, we can look up, right? What happens is there's some sort of physical mechanism, right, that kind of shuts off a valve somewhere, right, where the air will be released and the other air is retained. I don't know. That's a really, really good question. Somehow the body does it, but I don't know the answer as to why. Any other questions about that? I love how deep you are thinking about this. All right. Here comes the best part. Okay? The best part. All right. We are going to do a little compare and contrast right here. What do we notice in this picture?
They're really cute.
They are cute. Those are puffins. How am I doing on time? Okay, excellent. Those are puffins. What else are we noticing? Rocks? What's on the rocks?
Bird dropping.
Yeah, bird excretion here. It's not actually bird poop. This actually is kidney waste. So I need another assistant that would like to come up and help. Anna, you want to come up and help?
Okay.
I'm diming you out right now. I love it. Are you okay with that?
Okay.
Okay, I'm going to make you
You
exercise.
saw my raising my hand.
Yes, perfect. So you're going to grab that jug of water.
Okay.
You're going to hold it down like this, and you're going to act like it's a barbell on the count of 3, and you're going to do 20 reps. You're as many reps as you can,
Okay.
right? And the question that we're testing right now is water heavy. Is water heavy? Are you ready? All right. 1, 2, 3, go. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, 6, 1,000, 7, 1,000,
I'm fully
8,
expecting
1,000,
me to
9,
really buff
1,000,
biceps
10,
after this.
1,000, 11, 1,000, 12, 1,000, 13, 1,000, 14, 1,000, 15, 1,000, 16, 1,000, 17, 1,000, 18, 1,000, 19, 1,000, 20, 1,000. Yes, everyone please give Hannah a round of applause. Hannah, I know you have access to our materials, but you might not have some of these items, so feel free to take one if you like. I give it to you anyways, but we can actually, as a reward. Yes, take a button. I love it. Yeah, very good. So, was water heavy?
Yes.
Yeah, right? But pretty much every animal needs water to live, right? So how do birds minimize that weight while still getting the water that they need? Well, pretty fun fact, they have an incredible adaptation where birds, you look, these are the exact same size. You can say this is a small mammal. This is about, let's pretend this is how much it drinks per day. This is how much a bird of the same size needs. It's about 1/8 of what a mammal needs. How does that work? Well, in our bodies, a lot of why we need to drink water or have water come into us through osmosis is to get rid of, to flush out waste. So through our metabolism and other chemical processes, right, we actually create toxic waste in our own body that if it were to build up and build up and build up, it would kill us over time. So we have to have ways to get rid of it. And we do that by defecating, right, or urinating, right? We have to get rid of that waste. Hold your question for 1 second, Henry. Thank you. Does anyone here have a cat?
Yes.
Yeah, have a cat. You ever clean the litter box? Let's hope that's a yes. Yeah. PU, right? What you're smelling is some of that toxic waste. That's ammonia, right? Highly toxic. Needs to get rid of it. They have to excrete it. And for mammals who live on the ground, we can drink more water. We're not worried about weight necessarily, right? Water sloshing around, no big deal. But birds who are trying to stay light, to get up in the air, they need a system to minimize the amount of water they drink. Listen, now I'm going to ask you to come up and help me now. We're going to do a little experiment. So birds actually have something, instead of urine like we have, they have something called uric acid crystals. This is not uric acid crystals, this is sea salt, FYI, but it's for our intents and purposes, it'll act as our uric acid crystals today. It's a crystallized version, right, of like urine, that's highly, highly concentrated, okay? So think about this. So listen, what I'm going to ask you to do is pour this little baggie into the water and then stir it with a spoon. Okay, as Lucinda gets that ready. And do it quickly if you could. Thank you. What's going to happen here? Let's hypothesize. What's going to happen to these salt crystals in the water? What do you think, Henry?
It's gonna,
Go ahead and pick it up so everyone can see.
It's gonna soak into the water and eventually evaporate.
Oh my goodness, exactly so, right? So you mix it together, right? And that's actually going to dissolve in the water into a solution. As you can see, it's dissolving, right? The crystals are going away. It's becoming a solution. But what happens if we just leave this for months, this solution for months at a time? If we leave it here and we come back 3 months later, is it going to look like this?
No.
What's going to be different about it?
It'll settle out.
All of the salts would be at the bottom, and also because we're leaving it away for that long of a period, the water might evaporate.
You're absolutely right. The water is going to evaporate over time, but the salts don't evaporate with the water, right? What's going to happen instead? Thank you, Lucinda, for demonstrating. Perfect. Thank you. I know you didn't think that was chemistry, but it is. They're making a solution here. Dissolving a solid into a liquid. What's going to happen is those crystals are going to recrystallize, and that's actually what you're seeing right here on the rocks. You're seeing that those uric acid crystals that were in a little bit of water in the bird's cloaca, right, mixed together. They were able to excrete it out of their body. That water evaporated, and you're seeing these like powdery crystals left over. So now, if you've ever wondered why bird excrement is white, now you know, which I think is really, really amazing. This is just a little extra, little physics here. Why do we perceive it as white? How do we see it as white? Well, all visible light in the electromagnetic spectrum bounces from this white surface, right? It reflects, goes to our eye, and we see it as white. That's how we perceive it as white. All right, my friends, that's it for today. I'm going to open it up to questions, both on Zoom and here in the room, though you've been asking some great questions as we've gone along and been contributing a lot of cool knowledge. We do a lot of these free programs here at Carrillo National Monument for kids groups as well as the general public, so please check our website and our social media regularly so that you don't miss out on any of these programs if you enjoyed today. And thank you. Thanks for coming. Yeah, I see a question right here.
Well, it's a comment for those of us of a certain age, when you were talking about the precepts of flight,
Yes.
the TV show The Flying Nun.
Yeah.
The line Sally Field used that time and time again. How can you fly? It says it's simple. Anytime lift plus thrust exceeds drag plus weight, anything can fly.
Oh, I love it. I'm going to use that. Anytime lift plus thrust exceeds drag plus weight, it can
Anything
fly.
will fly.
That is awesome. That's fantastic. Thank you for that. And I do remember that show, actually. Yes, Ren, go for it.
If you go back to the color
Mhm.
one.
Yeah.
With the color, with the rainbow.
Yeah. Oops. Let's go back to it. Here you go.
There's a fact that if you I'm telling you facts. Well, so if there's a color like red, you're seeing every single color but the color red.
Right, exactly. So it depends on what's being absorbed and what's being reflected, and that's how we see different colors. You're absolutely right. That's why leaves look green to us. There's a molecule called chlorophyll where it absorbs all of those colors except green, which bounces off and comes to our eye. Yeah, very, very good. I love that. Yes, you're thinking deeply. Go for it. Question.
So when humans and other mammals exercise heavy for extended period, one of our limitations is you get lactic acid building up in the muscles.
Yes.
Which is painful and what all, and it limits being able to go indefinitely. Do birds, particularly the ones that can fly like thousands of miles, do they have problems with lactic acid, or is their system different?
Yeah, that is such a great, deep question. And again, I don't know the answer to that question.
Okay.
There's going to be some sort of adaptation, right, that allows them to fly for that long, and whether it's they process the lactic acid well in their body or that it doesn't build up is a good question. And here's another research question for after we're done for today. And I will look that up, so I'll make sure the next time. I love it. Other questions? Henry, go for it.
If birds just lose one bone, can they not fly? Can they not do certain things?
Yeah, that's a really good question. I think it depends on which bone that they were to lose, right? So if it's called a little pygostyle back here. It's the fusion of their coccyx, like this whole area back here, it fuses into their vertebra, into one bone back there. If they were to miss some of that, probably fine. It's kind of where their tail attaches to. I think it depends, but you're right, like things that hold their flight feathers, probably not, right? If they lose a wing, they're definitely not going to be able to fly. So I think it depends. Good question though. I bet somebody's researched every single bone that a bird could lose to be able to fly. Thanks for joining today.
Thank you so much.
Bye guys, take care.
Bye.
Yeah. Other questions or comments? Yes,
You know,
Josh.
hummingbirds have these luminescent feathers, I guess, that
Yeah.
show color. Does that have a purpose?
Yeah.
And do other birds have that characteristic?
Yeah, I love that you asked that question. So Josh was referring to the iridescent feathers of hummingbirds, and there are other birds that have this as well. Like the lazuli bunting is a really a good example of this. And here's what's interesting. Birds' feathers, you can see color in birds' feathers for a couple of different reasons. One is a chemistry reason, the other is a physics reason. So some birds deposit, molecules, pigment, in their feathers. That's the chemistry reason, right, that we see. We see that blue pigment, right, in their feather. Other birds, it actually has to do with absorption and reflection of light. So it's a very specific feather structure that absorbs a certain wavelengths of light and reflects others. So the Anna's hummingbird, for instance, you have to catch it right at the right angle where the light is reflecting off and hitting your eyes. This is why you'll see it and you'll be like, oh, it's green, and then it turns its head and it's bright pink and bright red, right? And that's the physics reason. You can actually see that color. So it's pretty amazing, right? It's like, again, nature is incredible. The more you take a deep dive, the more miraculous it seems.
Is it for mating? Is it for any purpose though, or is it just beautiful? It's just beautiful.
Yeah. Ooh, great question. Is there a purpose to beauty? And generally, almost always is for sexual selection. So, same reason why we like to put on makeup and, you know, kind of
Yeah.
get dolled up and look good, right? It's almost always for sexual selection. Yeah, you got it. Henry?
Do birds see like leaves if they're green? Do they see them a different color or the same?
Yeah, great question, Henry, because you know animals perceive things differently than humans do, right? So we actually have 3 pigment rods in our eyes. They have 4. So birds can actually see in the ultraviolet spectrum. So what birds are seeing are different, like we can't even perceive what it looks like, right? So little brown birds to us, we're like, oh, it's so boring. They're way more vibrant to birds than they are to humans because we can't perceive stuff in that spectrum, right? In the ultraviolet spectrum, which I think is just incredible. Great question. Other thoughts or questions about birds? Are there any on Zoom, Dan?
No.
No? Everybody's appeased on Zoom. Satisfied customers. Anyone else? All right, that concludes today's presentation. Thanks, everybody. It's great having you here.